to our next speaker, which is going to be actually a presentation about the United Solar Challenge 2021. It is coming to the Middle East for the second time, and it is actually a global students' competition of building solar-powered cars. The teams that participated to the first competition in 2015 covered a distance of over 1,100 kilometers in their solar cars. Now, the only car in the UAE which is solar is from Khalifa University, and that's exhibited outside in that direction, if I'm not mistaken. So if you haven't seen it, just make sure that you pass by it. And more about the United Solar Challenge is going to be presented now by Dr. Nabih Bedawi, whom is joining me on the stage. He is the Managing Director of Global EE and board member of the International Solar Car Federation. Dr. Bedawi held several professorial and research positions within organizations and universities in the DC area, worked on various projects at NASA, Goddard Fly Space Center, where he directed research in space systems and robotics. Again, as with all of our other speakers, there is so much more to be said about Dr. Bedawi, but I think it's fair to invite him to the stage for the presentation. Just give him a big round of applause, please. Thank you.
Thank you. Good afternoon. Can you hear me okay? Okay. I don't know who's doing the slides. So the topic of my presentation, and it will be about 15 to 20 minutes, is about the United Solar Challenge. And the purpose of these kinds of challenges or competitions is to encourage university students to go beyond the classroom, to actually design something, build it, race it. And most of these, as you will see now, are quite complex. They're not simple university, small projects that you can do in a laboratory. These are actually vehicles that are driven on public roads for thousands of miles or kilometers. The next slide, please. So we always like to say, what can you achieve when you combine technologies from the Formula One, satellites, renewable energy? And what you get is, next slide. Is this okay? What you get are solar cars, solar-powered cars. So solar-powered cars are vehicles that look like UFOs, but essentially it's a satellite on wheels. It's a vehicle that is super efficient, very light, made of composite materials, and the only source of energy is solar. And so you can imagine anyone who works in the solar industry, the amount of energy that is produced with the solar, with a surface area that's limited to a vehicle, is not very much, maybe 1.5 kilowatts at best. So you have a 1 horsepower motor which has to propel a vehicle 120 kilometers per hour in the middle of the desert indefinitely. And so the technology within that is quite high. Let me see how to do this. There you go. So this all started in the early 1980s. A gentleman by the name of Hans Tolstrup, he's a futurist, who was thinking, why is it that we don't have renewable energy or future types of vehicles that could run on the sun? And so and he's not an engineer, so he asked engineers, and they told him he cannot do it. So he said, okay, so he tried it. He went ahead and he actually built a car. And it looked like a bathtub with a big solar panel on top. And then he took a trip from Perth, which is on the west side of Australia, all the way to Sydney on the east side. And his target was to arrive at the new year. And he did, and it was a big event. People were hearing about him in the news, this crazy Danish guy, driving a solar car. And when he arrived, everybody said, okay, you can do it, but this is a piece of junk. This is not a real car. So he said, fine, you are engineers, make it better. So he challenged the world. He created the first World Solar Challenge, which was held in Australia in 1987, a little bit over 30 years ago. And teams were formed by General Motors, Ford, eventually Toyota, Honda, Mercedes. Everybody got in on the challenge. And the first event was actually won by General Motors. They crossed Australia in a little bit over 4 days, purely on sun power, beautiful car. The year after that, General Motors decided to sponsor the first university competition in the US, and there were 30-some universities from the US that participated. And that was the beginning of the solar challenges that we know of today for universities. And you can see some of the races that have taken place so far. While at the bottom, You can see the Moroccan Solar Challenge. We have the Abu Dhabi Solar Challenge, which we held 4 years ago, and so on. So a little bit about the organizations. There's the International Solar Car Federation, which I sit on the board representing the Middle East and North Africa. And this organization oversees all the solar challenges. And our objective is to make sure the events are safe and fairness, and also to homologate among the different events with regulations. We're the FIA of solar challenges with a zero budget. And then the organization that I actually run is Global EEE, which is the organization that puts on these events. So we organize competitions from middle school all the way up to university competitions. And the objective, our mission, our objective is to develop better engineers that understand energy constraints, energy efficiency, renewable energy, electric vehicles, and are well prepared for industry from a both perspective of their hard skills, engineering skills, as well as their soft skills. I'll skip through these. So these are the different challenges around the world, the solar challenges. We have the American Solar Challenge, which takes place on even years, every even year. The Atacama in Chile, in the desert of Chile. European, we have the Australian, which is the biggest one every 2 years. And these are all cross-country challenges. The vehicles are built and they're driven across country. When we did the event in Abu Dhabi 4 years ago, it actually went across the different parts of the Emirate of Abu Dhabi, all the way to Al Ain, Zayed City, where Shams 1 is, and so on. So this is one of the vehicles. It's about a 7-8-year-old vehicle from Nuwan. Actually, we have one of the Nuwan team members back there. Adri, say hello. But if you look at every box that's labeled here, it's a technology that is advanced. There's composite materials. There's wheel electric motors, which are super efficient. Telemetry system that's communicating the data in real time. The aerodynamics, of course, is super important. Low rolling resistance tires. All of these aspects, which if you take any one of these boxes, could be a project in and of itself. And the students work for 2 years to actually build a car that encompasses all of these technologies. And some of the budgets are well over $1 million. These are not inexpensive vehicles. This is actually a plot from the Nuwan chase vehicle. You can see it looks like a satellite mission control. And here, the van that follows the vehicle is getting real-time data from the car. In fact, they can control the car from the van. And there's download of real-time weather data information. And if something ever goes wrong with the vehicle, they know it in the van behind, just because the efficiency of the vehicle is so high that if it starts to draw a little bit more energy than they expect, they know something's not right. Could be that a tire is low. It could be that something is wrong with one of the solar cells, not the panel, but one of the cells, and they can immediately troubleshoot it from there. So let's talk about the United Solar Challenge. The United Solar Challenge is an event which is for the Middle East and North Africa. It's on the calendar of the International Solar Challenges, and the intention of it is to move every 2 years. So in '95 was the first one, which was held in Abu Dhabi. We did one in Egypt in '97. There's one that we do in Morocco every year. It's a smaller event. And the planned next event, as was mentioned in the introduction, is in 2021 in Dubai. And the name United actually is not necessarily United Arab Emirates, but actually United as in uniting the Arab world or the MENA region, which is a dream, but hopefully someday. And what you see down there is the trophy on the right, which is the United Solar Challenge trophy. And it's awarded to the team that wins every 2 years. The last event, as mentioned, was held in Abu Dhabi, and it coincided with the World Future Energy Summit. So we were fortunate enough that the competition ended at WFES, and we had dignitaries that gave the awards. And we have Dr. Fad al-Maskari sitting back there, wave, with Khalifa University, who's actually in the photo next to the president of Iceland on the right. They had the fastest car at the competition, the team from the UAE. But unfortunately, they came in second because of some penalties and driver aggressiveness. But the team that came in first place was the team from Michigan, who was the champion basically the American champion for many years. Before I get into that, let's show a quick video, just to get an idea of, I don't know who's, just to give you a glimpse at how these competitions take place and how the cars. So before the challenge actually begins, we have 3 days of scrutineering or technical inspection. So we have officials from all over the world who come in and they inspect the vehicles, every aspect of the vehicle to ensure that they meet the safety regulations as well as the fairness regulations. And then we do qualifying, and in this case the qualifying was at Yas Marina, which is a one-day session for qualifying. And the teams must complete so many kilometers in order to qualify to participate in the challenge before they go out on the main roads. And they are issued license plates, so the Transport Authority of Abu Dhabi actually gave each car a license plate. They couldn't mount it on the car. As you can imagine, it disrupts the aerodynamics, so it has to be inside the canopy. In this case, the Abu Dhabi Solar Challenge was a staged race, which means that every day everybody begins in the same city and ends in the same city. It's a fixed number of kilometers. Some of the other challenges are open-ended. In Australia, everybody starts in Darwin in the north, and then we say, see you in Adelaide in the south. And they're spread all over the outback. And so the first team that arrives wins, and then 24 hours later, the event is over, and whoever completed within those 24 hours gets ranked. So at the end of the day, they just park on the side of the highway and camp. Whereas in Abu Dhabi, once you reach the end, you sit there and you can continue charging your batteries from the sun because the panels, of course, are functioning. And then you begin the next day for the next stage. Dubai is going to be a mix of the two. So it actually is a staged event. But in between, teams are able to clock more distance. So they can continue to do loops and get more distance. So this way, you don't get cars that arrive at 2 in the afternoon and just sit and charge. If they want to win, they're going to have to continue to clock more distance. So real quick, I mentioned why we do the challenges for the students, but over the years, these solar challenges have had a tremendous impact, and a lot of it you're seeing today, but you would not know it unless you actually knew what the history or the origin was. As a minimum, of course, we have thousands of engineers who are getting trained every year. Each competition might have 50 teams or what have you, and each one has 20 to 30 students, and these are students who dedicated 2 years of their lives working in a real environment. This is an environment where the regulations are the constraints. Imagine, the marketing department came and said, we need to develop a product, and these are the requirements. The regulations are that. And then with the regulations, then they start to do their design, and then they have to build prototypes, and they have to fundraise, and they have to have marketing. And they have a full marketing team, just like a company, that goes out and, and sells sponsorship and so on. And so by the time they're done, these kids are ready for work better than probably somebody who's been working 5 years. So as a minimum, we get this. But at the same time, a lot of the companies that build technologies related to this test their technologies through these competitions. So when I was involved, I was actually in charge of a university team back in the early 90s. Bridgestone was our partner. And so they were developing new compounds for tires to test higher efficiency tires. So when you put this tire on your car, you get better fuel economy. So they would make tires, of course, they didn't look anything like a real tire. They would make it especially in the shape that we want, but it's that compound. And today, the tire that we were testing, you can actually buy commercially in a Bridgestone. It's called the Ecopia. In fact, now it's Ecopia 2. It's the second generation. So Bridgestone gets a lot of mileage out of the sponsorship by actually providing new technology. The solar cells, most of the solar cells that you see today, these companies, when they build their solar cells, whatever their latest technology is, the highest efficiency, where it's 0.1% of the batch that they produce goes to a solar car team. And they constantly are pushing to see who has the better cells. And so 1 year SunPower might be ahead, another year Trina might be ahead, and they're doing this. Maximum peak power trackers. Today, every solar panel installation that you have out there has a little box that optimizes. The first one was designed by a solar car team specifically for this reason. Now it's a commercially available product. And the list goes on and on. There are actually companies today, there are 2 companies, spin-offs, that are building actual commercial solar-powered car. You can actually buy a real solar-powered car, like a Tesla, that is solar-powered by 2 of the teams that were competing. They're not commercial yet, but they should be probably within a year. And I'd be happy to share some of the information on. One other thing to keep in mind is that a lot of the car companies, the electric cars that you see today, were designed by people that participated in these competitions. So in the early days, GM, General Motors, I mentioned, they participated in '87. The EV1, which is the world's first electric vehicle, was actually designed by that team. After they finished the World Solar Challenge, they came in, they gave them an office space in GM, and they went off with AeroVironment, and they produced the EV1. The Honda Insight, which is the first hybrid car that Honda made, was designed by the Honda Dream team. The Swatch, which actually is today the Mercedes Smart, the smart car, was actually called the Swatch Mobile. It was designed by the Swatch solar car team that won the 1990 World Solar Challenge. And then the company was sold off to Mercedes. And then at the bottom you have Mercedes. If you go to their museum in Stuttgart, you'll see their solar car on the wall. So they use these as opportunities to train their engineers on how to build electric vehicles and also to develop technologies. Tesla, if you look at their engineering staff, a big percentage of them are solar car kids. Their chief technology officer, in fact, who just left 3 months ago, is from the Stanford University solar car team. The company was formed by, not Elon Musk, it was actually formed by a professor at Stanford with a group of students from the solar car team. And then Elon Musk came in as an investor, and then eventually, of course he made it what it is today, but the origin of the company is a solar car team. I think I'll skip through a couple of these. Oh. So, to talk again about the United Solar Challenge, the plan is January 2021. The idea is to coincide it with the Expo 2020 within the 6-month period. January is a good time for us because a lot of people say it's winter, how will the solar cars do? Well, that's part of the challenge, right? if you did it in the middle of the summer when the sun is out all day, where's the challenge? So now it offers an additional challenge. January is a good time for universities because it's in between their semesters, so you tend to get more teams. But it is an international event. We plan to attract the top teams in the world to participate. We expect probably 25 to 30 teams internationally. And anybody who's involved in anything remotely related to any technology that I shared and would like more information, please, I'd be happy to speak with you afterwards. If you're interested in sponsorship, of course, many opportunities for sponsorship. And that's it. Yep. Thank you. I'll take questions. Usually I hate to ask that because if there are no questions, it tells me everybody was sleeping when I was talking. Just throw one question. Anybody, just Ms. Habiba, yes.
Thank you very much, Doctor. Wonderful presentation and so innovative and inspiring. I'm sure you are facing some challenges to be able to enter into the region, whether it's GCC or the Arab world. Can you share, please, with us what are the challenges that you are facing, particularly for the benefit of the private sector, and how can we overcome those challenges?
So thank you, Ms. Habiba. This is a very good question. So every event that we do faces some form of challenges. In fact, we call it a challenge. So it's also an organizational challenge. So in order for an event like this to take place, there are two aspects. There are the teams, and then there's the organization itself, and the government, and the venue. So something like a solo challenge, for the teams, the barrier to entry is a little bit high. For a university to actually build a solar car, there is a substantial barrier to entry. They have to get funding. They have to mobilize a team of students. Professors have to be on board. More importantly, the administration has to be on board. They can have the best design on earth and they can have a budget, and then they go to buy a motor and the university says, well, you have to go to procurement and we need 3 bids and this and that. Well, there's only one company in the world that makes that motor that everybody's using. And so you end up spending 3-4 months waiting for parts, and then they miss it. So there are and this we call the culture within the university. You have to build the culture to support these kinds of projects. So number one is the barrier to entry, I think, is high on the teams. On the side of the event itself, there has to be support from the government. You cannot go driving on public roads in funky-looking cars. So getting the support of the government is important. And usually, and we were very fortunate in Abu Dhabi with Masdar being on board, and they were able to put it under the patronage of His Highness Sheikh Mohammed bin Zayed. That immediately changes everything. Now the Transport Authority is supportive. Everybody is helping us. But also funding. To make an event like this happen, there are many people. There's about 40 people that actually work on the event, not event management during the last 2 weeks. Technical people for a year who are getting reports from the teams, structural reports, battery management report, fire reports, safety reports, solar cell reports. and they have to review them and send them back. And this is somebody who's actually reviewing something that could potentially be dangerous to a student. You know, you're going to put a student in a vehicle 110 kilometers per hour in the middle of nowhere, and his life is in your hands. And you know, we've been extremely fortunate, I think, through very strong due diligence and technical strength to make it happen. So the funding to do this is not you know, insignificant. So what we've done is we've actually established competitions that are slightly less complex as entry-level competition, like the Hybrid Electric Challenge, which actually we're holding one starting tomorrow in Dubai, right here. And if you like more information afterwards, I can provide you that information. But those competitions are on a track as opposed to a public road. So now it reduces the risk substantially. It makes the budgets are limited, around $10,000 per vehicle to actually do that. And it helps the teams build the culture. It helps them build the know-how. And if you have a success or two, then suddenly the university starts to support you and fund you. And then also you'll see them in like many of the events like this event. You'll see the hybrid cars, we call them hybrid cars. You'll see them actually on display. And then a minister might be going by and, you know, what is this? Oh, well, you know, come talk to us. We would like to, you know, support you and so on. So it actually helps them get the programs going, and then they can build it. So one of the biggest, of course, success stories here is Khalifa University, and I mentioned Dr. Fahd earlier. Their car is on display outside, and it's one of the best cars in the world. Now, the car is about 3 years old, so it doesn't meet the most current regulation. The current regulations change every 3 years, but it's still actually one of the best cars ever built in the world. And Khalifa University participated in the hybrid competition for a couple of years, you know, used that, but then the university was extremely behind it. You know, they supported the students, they supported the faculty, and the funding as well. Okay. Well, thank you very much. Thank you, Ms. Habib, for the question.
Thank you very much, Dr. Bedawi.